To anyone who sails, this isn't just a map. It's a lifeline. A nautical chart is honestly one of the most information-packed documents on the entire planet. And knowing how to read it, well, that's what separates a safe trip from a very, very bad day. Every single symbol, every number, every splash of color on here is a critical piece of a really high-stakes puzzle. If you get it right, you find your way into a safe harbor, but if you get it wrong, the sea really doesn't give you a second chance. So in this explainer, that's exactly what we're going to do. We're going to crack that code together. We'll break down the secret language of the nautical chart, piece by piece, so you can look at one of these and read it with total confidence. Okay, first things first. Before you even try to figure out where you're going, you have to read the manual. And for a chart, all that essential info is tucked away right in the title block and in the margins. Think of this whole section as the chart's passport. It tells you who published it, its unique ID number, and the projection they used to get our round Earth onto a flat piece of paper. Now, all of that's important, but there are 3 things you absolutely must check every single time you look at a new chart: scale, units, and corrections. All right, so chart scale. This is famously a bit weird and counterintuitive. A large-scale chart actually has a smaller number, like 1 to 10,000. It shows a really small area, like a harbor, but in incredible detail. On the flip side, a small-scale chart has a bigger number, like 1 to 150,000. It shows a massive area for planning a long trip, but way less detail. So just remember this: big number, big area, but less detail. Small number, small area, more detail. And that brings us to something that is just critical. You always have to check the units. Is the chart using meters, feet, maybe even old school fathoms? It's usually printed in bright magenta so you can't miss it. Getting this wrong is probably one of the fastest and easiest ways to run your boat aground. Okay, so we've got our chart identified, but how in the world does a flat piece of paper show us a 3D world with different depths and heights? Well, the answer is this really clever concept called datums. The most important one of all is called chart datum. Just think of it as the ultimate 0 point. It's the absolute baseline that all depths on the chart are measured from. And on most international charts, this is set to the lowest astronomical tide, or LAT, which is basically the lowest the tide could ever possibly get. But here's where it gets really smart. Not everything is measured from that same 0 point. The depths? Yeah, those are measured from the lowest possible tide. But the height of a lighthouse, that's measured from an average high tide. And the clearance under a bridge, that's measured from the highest possible tide. Are you seeing the pattern here? It's brilliant. It's all about building in a safety margin for you, the navigator. This is maybe the single most important safety feature of any chart, the fail-safe principle. It is designed from the ground up to show you the most conservative worst-case scenario. The real depth will almost always be more than what's on the chart, and the actual space under a bridge will almost always be greater. The chart is basically your cautious best friend. All right, we've got the chart's ID and we understand how it handles 3D. Now for the fun part. Let's decode the actual visual language. This is where colors and symbols give you that instant at-a-glance picture of what's around you. The color code is super simple, but really powerful. Yellow is land, easy enough. Green represents the intertidal zone, so areas that are covered at high tide but exposed at low tide. Blue means shallow water, and white means deep, safe water. Just by glancing at the colors, you can already see the basic layout of the seabed. And get this, even the font style tells you a story. If you see text written in italics, it means that feature is affected by the water level. It might be floating, or it could be a wreck that's underwater at high tide. But if the text is upright and bold, that feature is fixed. It's always above the water, like a lighthouse or a big chimney. It's such a simple but brilliant clue. The symbols get even more specific, especially for dangers. Let's take rocks. A little rock symbol with some shading means it's always visible. But a simple plus sign, that means the rock is awash. It's sitting right at the surface at the lowest possible tide, which makes it incredibly dangerous. Different symbols are meant to communicate different, very specific levels of hazard. So far, pretty much everything we've talked about has been static. But charts also have to communicate information that changes, especially for navigating when it's dark. And that's where we get into the language of lights. Every major light has its own unique signature, kind of like a fingerprint, and it's printed right next to it on the chart. Let's break this one down. Flag 3 tells us it's a flashing light in a group of 3 flashes. 20S means that whole 3-flash sequence repeats every 20 seconds. 28M is its elevation. It's 28 meters above the average high tide. And 28M is its nominal range. The bulb is bright enough to be seen from 28 nautical miles away on a clear night. And you'll see a few different rhythms out there. Flashing means the light is off for longer than it's on. Occulting is the exact opposite. It's a steady light that just blinks off for a moment. And isophase means the on and off periods are perfectly equal. Each unique rhythm helps you identify exactly which light you're looking at on the horizon. This brings us to a really important point. A light actually has two different ranges. The nominal range, which is what's on the chart, just tells you how bright the bulb is. But the geographical range, that tells you how far away you can see it before it literally disappears over the curve of the Earth. A light might be bright enough to see from 28 miles, sure, but you won't actually see it until you're close enough for it to pop up over the horizon. Okay, so this all leads to the big question, right? The one everyone asks. We all have GPS chart plotters, we have nav apps on our phones. So is all this knowledge about paper charts just obsolete? Is it a thing of the past? The answer is a huge, emphatic no. This knowledge isn't about paper versus a screen. It's the fundamental grammar of navigation. It's about actually understanding what all this information means, no matter how you're looking at it. Why? Because your electronic chart uses the exact same symbols, the same colors, the same datums. The safety principles we just talked about, that's the logic that powers the pixels on your screen. Understanding this stuff is what separates someone who's just a passenger from someone who's a true navigator. So the real skill today is knowing how to blend this timeless knowledge with our modern technology, and how to do it safely and effectively. And that's a great question, and it's exactly what we're going to cover in part 2. I'll see you then.